Hi friends, today let's talk about Chapter 4 of Design Data Intensive Applications. This chapter covers encoding format and its evolution. We'll first talk about why do we need encoding, and then we'll talk about 3 different encoding formats, including language-specific ones, text-based, and binary encoding. And next, we'll talk about 3 modes of data flow via databases, via services, and via message passing. So let's get started. So first questions first, why do we need encoding? Essentially, encoding and decoding, they exist in the context of communication between multiple nodes. So if you only have one single machine, then all your data is stored in memory in object. However, if you want two machines to communicate, then you need to export your data into bytes, and then the other machine need to receive your data. So you see there's this sender and receiver relation here. Compatibility basically means that sender can send data to the receiver and receiver is able to read the data by the sender. Encoding means that when sender sends data to receiver, it needs to convert its object to bytes. So the process of converting object to bytes is called encoding, and the reverse is called decoding. So again, we talk about the sender and receiver relation. So we talk about code that write data and the code that read data. So forward and backward compatibility is all about reading data. So if the code can read data that were written in the past, it's called backward compatibility. And in contrast, if your code can read data that will be written in the future, it's called forward compatibility. So let's quickly summarize. Compatibility means that the receiver can read the data sent by the sender. It can communicate, that means compatibility. And forward compatible means that your code is able to read data written in the future. Or you can imagine the old code can read data that is written now. And backward compatibility means that you are able to read data written in the past. And essentially encoding here means that encoding means the process of converting object to bytes, and decoding is vice versa. Now let's talk about the 3 encoding formats. Essentially, we have these 3. We have language-specific encoding format. Basically means that for some languages, they have their own encoding format. For example, Python has Pickle, and Java has serializable, and Ruby has Marshall. So there are pros and cons on this in that you can't do cross-language communication with these language-specific ones. And also note that this language-specific encoding format, you don't enforce an explicit schema, whereas for text-based and binary encoding format, you do enforce schemas explicitly. So for text-based, we have JSON and XML. They're human-readable, but at the cost of being verbose. So binary encoding is the contrary. They are more compact in that they directly encode the data into bytes, but they also lost their human readability. In that sense, binary encoding, because it's compact and efficient, it is good for low latency applications. Within the binary encoding, there are 2 types. One is protobuf, the other is Avro. The key difference is how to define schema. Essentially, with JSON and XML, the schema is more like depending on the JSON field and XML fields. But for binary encoding, the schema is defined differently. So for protobuf and thrift, it's more like static typing in terms of schema definition. So it's based on tags, whereas as Avro, it's used JSON to define a schema. Compared to protobuf and thrift, Avro is like dynamic typing. So you can think about it. When you want more flexible schema evolution, you want Avro. When you want more linear and smaller change in your schema, you want to use protobuf or thrift. So protobuf and thrift are basically similar. One is from Google, the other from Facebook. So let's now do a summary. So for language-specific encoding format, it is relatively simple to encode, but the drawback is that it doesn't support cross-language encoding and decoding. And for text-based encoding, it is human readable in terms of it is using JSON and XML as format, but it comes at the cost of being verbose and chunky. For binary encoding format, they are more compact compared to text-based because they explicitly claim their schema. But this also comes at a cost in that it is no longer human readable. So you can think about this as language-specific ones. They don't really have a schema, and text-based encoding format, they have schema implicitly. The application code has to read the JSON and XML. And for binary encoding ones, they explicitly write and define the schema. So now let's talk about 3 modes of data flow. What do I mean by data flow here? We just talked about the purpose of encoding data into those different formats is that we can communicate data between different nodes, basically saying that multiple machines communicate with each other. When this thing happens, you have to encode data. So, what are the modes of different machines communicating with data? That's what we're going to talk about. Essentially, there are 3 modes. There are databases, services, and message passing. So they differ with each other in terms of how long the data lives and how asynchronous or synchronous the process is. So for database, when a service interacts with databases, the read requests and write requests are oftentimes individual requests. When a service interacts with databases, the read and write are separate. And because of the nature of databases, you are very likely to read the data that may be written 5 years ago. You're also likely to read the data that is written 5 seconds ago. So essentially, in databases, data outlives code. When you define data schema and encoding format of databases, you want to really think about forward compatibility. Second mode is via services. We can use an example as web service. So if a service is built upon HTTP, it's called web service. The difference between service and databases is that databases has less restriction on how you read and write data, whereas services it only exposes certain APIs to the client. In addition, service is more synchronized. That's why I use phone call as an analogy here. The difference of data flow via services and via message passing is that message passing is asynchronous. That's why we're talking about it as a text message. Overall, here's an analogy. If you are talking to your friend through a phone call, your friend has to pick up the call right away. You, as a sender, are expecting a response from the receiver right away. So your communication with your friend is like data flow via services. And in another scenario where you talk to your friend through this text message, you send this text and this text is received by some middleman in the service. And this text is received and stored in, for example, iCloud or in some cloud service. And your friend will read it later. You don't expect your friend to read right away. And this is message passing. And next, we also have letter. When you write letter, it's usually very formal. You expect this letter to be stored somewhere for a very long time. So this is similarly to communication and data flow via databases. So data flow via databases are relatively straightforward. Now let's focus on data flow via services. There are mainly 2 design patterns that we talk about here. One is REST, the other is RPC. One way to tell the difference is really by looking at their encoding format. So JSON is the most common encoding format of REST APIs, and the protobuf is the dominant one for gRPC. So as when you look at encoding format, you kind of know the difference. With JSON, it's always usually human readable and web friendly because you can debug by web browser. With protobuf, it's compact. It's good for any low latency requirement applications. This encoding format signifies the difference of REST API and RPC. Because of this, REST is good for public-facing APIs, and RPCs are usually used for internal service communication because it's compact and efficient. In addition, what worth noting is that REST is really built upon the HTTP philosophy in terms of it uses the verbs of HTTP. including get, post, update, and delete. It uses verbs to manage resources in the format with slashes like this, like web pages. So REST essentially is resource-oriented. It reflects the resources and represents the resources using this URL. In contrast, RPC is more action-oriented. It defines classes and functions. So RPC means remote procedure call. So it really tries to model the remote function calls similarly to functions. This has been changing in the modern RPC design. RPC APIs are action-oriented, so it tries to define functions and verbs. Where REST APIs, they reuses the HTTP verbs. So the design of REST APIs are more resource-oriented, and notice that they also are using different encoding format. Next, we talk about data flow via message passing. Compared to services, message passing is asynchronous. And here, we talk about two types of message passing. One is called message broker, the other is distributed actor framework. So for message broker, it essentially decouples send from receive. So it does so by injecting a middleman here between producer and consumer. We call it message broker. So what it does is that with a message broker, the producer won't care about the consumer sending a response back or not. It just cares about sending the message, sending the data to the message broker. And message broker will be responsible as a buffer to send the message, the data to the consumers. So it is particularly beneficial when we have multiple consumers and some consumers are not available to receive the data. The second one we have is distributed actor framework. So they solve different problems than message broker. So message broker, you can think about it more like data integration. There's upstream data as a producer and downstream application consume this data. Such use cases are mainly for integration purposes, and you can think about some common open source tools like Kafka doing such job. But we also have distributed actor framework to solve a different problem, which is parallel computing. And an open source example is Ray. So in distributed actor framework, instead of directly using multi-thread or multi-process, we define an actor. An actor is an object with a mailbox. So when different actors interact with each other, if you send message not directly to the actor, but to the mailbox of the actor. So and then the actor 2 will process all the messages it received from its mailbox sequentially in a message queue. The runtime will be responsible for rescheduling the actors, and actors can be implemented either through multi-thread or multi-process. So back to the encoding format here. So for the message broker, it actually is coding format agnostic. It can pass through any encoding format. So as long as you make sure you're controlling the forward and backward compatibility of the encoding format, usually you can maintain the data compatibility. So for encoding format, Ray uses multiple formats, including Apache Arrow, but also sometimes Pickle and Cloud Pickle. To wrap up, we talk about three types of encoding format. The language-specific ones that does not have a schema, the text-based ones that has implicit schema, and the binary encoding ones that have explicit schema. And then we talk about three modes of data flow. Data flow through databases that are like letters, where data outlives code, and data flow through services, which is like a phone call. It must be synchronized. And lastly, data flow through message passing. It's like a text message where you send now and expect the receiver to read later. I hope you enjoyed this video. We'll see you next time.